Hey, what's up, Bearcats? Mr. Steffens here. We are going to be going over some FRQs. You know that's what you want to do. Do the FRQs. This little AP review is going to help you with just giving you information you might need. So the first FRQ we're going to go over is 2014 FRQ 3. So hopefully you've got that done. Hopefully you went through it and tried it. Hopefully you checked your answer, you looked at the solutions that were posted and the scoring guidelines on the College Board website. Then you went through and checked and tried to figure out things you did. So maybe this will answer a couple questions if you have them about this problem. So first of all, you can see what type of problem it is. This is one of the problems where they're going to give us a graph. And the graph they're going to give us, we're going to have to do two things with it. We're going to have to, or three things, sorry. First thing is we're going to have to know all the values of the graph. And we're going to call all of those values f. And then we're going to also look at the areas under the graph. That's going to be the integral of f. And then we're going to have to look at the slopes of the graph. And that's going to be the derivative of f. So this is about the relationship between those three pieces. So we look at the first piece of this graph right here. Oh, watch this. This is the best part. I have answers on the back. It's magic. It's like magic. Look, boom, there you go. I went ahead and printed out the little solution thing so we could talk about where all these points come from. So when you take a look at this problem, zoom in just a tad. The first question says, I'm going to go from -5 to -4 on this graph of f. And then it gives me another function called g of x, which is actually the integral of the original function from -3 to x. So what that means is if I'm starting at -3, if I'm starting right here, the g of x is just the area under this graph. So it's going to say, hey, can you find g of 3? Well, cool, I can find g of 3, because you'll notice if I'm looking for g of 3, then that x is just going to be a 3. So I'm looking at the integral from -3 to 3 of my original function. So that's the area under this graph. So if I look at this graph and I have a triangle right here, the area under this triangle is going to be 6, base times height divided by 2. The area of this one, base times height divided by 2, is going to be 4. And the area under this triangle here, because if I'm going to go to 3, it's going to go down here. That area right there is going to be a -1. So that's where the -1's coming in. So 6 plus 4 is 10, -1 is 9. You get a point for that answer. Second question down here is going to say, on what open intervals is this graph both increasing and concave down? So remember, for increasing, I need to look at g prime, and for concave down, I need to look at g double prime. So they give us our graph, and they have the fact that this g of x is worth that. So let's think about it. If g of x is worth that, then g prime of x is going to be d dx of that. So you can tell if I found the derivative of g of x, I'm going to use this second fundamental theorem of calculus, which allows me to just plug the x into there, which means g prime of x is worth the same as f of x. So that if I have that information, I'm good. So it says, what is our number line going to look like? Well, so let's take a look at it. If g prime of x is just f of x, then in our number line for g prime, I've got a couple of values I need to look at. I have the fact that this is all positive up here. So everything here and here and here is positive. So the only number that I'm really concerning myself with is this number right here at 2. So at 2, I realize that since the area is negative, that g prime is negative. And since the areas over here are positive, g prime is positive. If I look at the g double prime graph, well, the g double prime graph is going to be the derivative of the derivative. So g double prime of x is f prime of x, which means it is the slope of f. So g double prime is the slope of f. So the slope of f here is negative. So all the way to -3, the slope is negative. And then from -3 to 0, the slope is positive. And then from 0 for the rest of it, the slope is negative. So I'm trying to figure out where is it going to be increasing and concave down. So where are the values where this one is increasing, and it's concave down. So this one does, everything starts at -5. So we have -5s here. So it looks like this one's going to be increasing and concave down in this first section. So that's where they're getting this. And then also it's going to be increasing and concave down all the way it gets from 0 to 2, which is this one. So you get a point each for that. Cool. All right, third part, pretty gross. It is a quotient rule. So quotient rule, I just have to find the quotient of h of x. So I have to find the quotient, the derivative of h of x and plug in a 3. So they did a nice job breaking down the quotient rule down here. Just in case you forgot what it was, it's really gross. So it looks like this. It is the bottom times the derivative of the top minus the top times the derivative of the bottom. So remember, when h of x is g of x over 5x, this is what breaks down. So you have to go through and work it all out. You do have to find g prime of 3. So remember, g prime of 3 is the same as f of 3. So g prime of 3 is f of 3. So if I go to 3 and I look at f, it looks like it's going to be at -2. So that's why there's a -2 here. And then g of 3 is going to be, g of 3 is going to be, hold on, let me think about this. G of 3 is the area. Oh, it's what we found up top. G of 3 is this area that we found right here, right? G of 3 was 9, so that G of 3 is just the 9. So that should give us a -1/3. You do get 2 points if you correctly found this derivative right here, and you do get 1 point if you correctly found that answer. All right, last question. It said I need this function right here. It says p of x is that. Find the slope of the tangent line at -1. So I need to find the derivative of this and plug in a 1. So the derivative of this, it's just a straight chain rule, guys. The derivative of this is going to be f prime of that, and then you have the chain rule of x squared minus x. So that's the derivative. And then all I do is plug in -1s everywhere. So I plug in a -1 and I plug in some -1s here, so that gets me f prime of 2. So I got to remember, what is f prime of 2, right? So f prime at 2 is the slope of f at 2. So I go over to 2. It's going downhill at a slope of -2. So f prime at -2 is -2. So my grand total is 1. All right. So hopefully you guys did okay with that one. Trying to eke out a 4 gets it done. See you guys later.